All right. Today we're going to talk about arcs and chords. Previously we've talked about what arcs are. They're part of a circle. We've talked about chords. They're segments whose endpoints are both on the circle. So if we have a circle, terrible circle, and we have two chords on the circle, one thing that's great about this is that if the two chords are congruent, then the arcs that they intercept are congruent. So this chord intercepts that arc, this chord intercepts that arc, so those two arcs are congruent. Conversely, if the arcs are congruent, then their intercepting chords are congruent. So that works out really nicely. Now, that also applies to the major arcs. This major arc would be congruent to that major arc. So if I gave these points names, A, B, C, and D, we could say that arc ABD is congruent to arc BDC because these chords are congruent. So it works for both the minor arcs AD and BC and the major arcs ABD and BDC. Now the chords and circles also create some other relationships. Let's say we had a chord. So I'm going to take my circle and I'm just going to make a chord. I'm going to call that chord AB and I'll have circle O. So we have chord AB and circle O. If you have a radius that is perpendicular to the chord, if you have a radius that is perpendicular to the chord, so I'm just going to call that point C and that point D, there are a couple things about that. So if your radius is perpendicular to the chord, then the first thing is that the radius bisects the chord. We can show that by constructing the radii OA and OB. We know since they're congruent that those two, we know that since they're radii that those two are congruent. We also know that OD is congruent to itself. So if you look at triangles AOD and triangle BOD, we can tell that these two triangles are congruent by our hypotenuse leg theorem. So since those triangles are congruent, we can go a step further and say that those are congruent. So the radius that's perpendicular to the chord bisects the chord. And by that token, since these triangles are congruent, that angle and that angle are congruent, and it bisects the arc. So if a radius is perpendicular to a chord, it bisects the chord and it bisects the intercepted arc. What's good is that the converse is also true. So if you have a radius bisecting an arc, it's perpendicular to the chord. If you have a radius that's bisecting the chord, it's perpendicular to the chord. All right. So let's go back to what we originally started with. We started with our first thing was congruent chords. So let's say we have these two congruent chords, A, B, and C, D. So AB is congruent to CD, which means that arc AB is congruent to arc CD. So we know those are true. If you have two congruent chords, your chords are equidistant from the center. So congruent chords are equidistant from the center. Remember, if we're doing a distance from a point to a line, it is perpendicular. So we are saying that is congruent to that. Once again, we can go back to our old standby of congruent triangles. So if I draw a radii of OA, OB, OC, and OD, we know that these are all congruent. By the definition of a circle, all the points are equidistant from the center. So we know those are congruent. We also know that these are right angles because we're talking about the distance from a point to a line. So we know for sure that that's a right angle and that's a right angle. So that means these are congruent. So all of these right triangles are congruent to each other by the hypotenuse leg theorem, and then corresponding parts of congruent triangles are congruent tells us that the chords are equidistant from the center. All right, so that's it for this section. Not a lot there, but it is pretty critical. It's pretty good stuff about circles. All right, see you later.